Greetings, everybody. I wanted to go over Valery Gourmet gifts database problem with you, and I wanted to show you the solution. So I wanted to make a video on it because I feel like we won't have enough time in class to adequately cover this. So I wanted to show you how this is done, and I actually filled in all the gaps, and I actually put the solution out in Moodle too. So let's just go over this right quick, and this will allow you to know how to do this and help you with your project. So I'm going to share out my screen right now with the solution. And as you notice, again, there's 6 basic steps for designing a database structure. Identify the data elements, subdivide each element into its smallest element, identify the tables and assign the columns, identify primary and foreign keys, and review whether the data structure is normalized, and then identify any indexes you may want. So let's go ahead and get this started. We start off with looking at a data flow diagram. And again, very simple. These circles, I know they don't look like circles, but they're circles. They are processes, okay? And whenever you see a line through something, that's actually, that's a data store. And so we have 2 data stores. We have orders and we have a catalog. And then the square is a customer, that's an entity. All 3 of these are going to have tables. I can tell you that right now. It doesn't mean they're the only tables, but this helps to identify what tables you definitely will need. So let's go on. And then we have an order form for a customer. And again, we're really not concerned with this information up here, but we are concerned with this information, the customer's name, address, city, state, zip, phone number. And then definitely want to know about this catalog number, how many you're ordering, that's a quantity, catalog description, price, and total price, okay? And you see that, so these will all become data elements. And we have some other data elements here. We have the method of payment, the credit card number. Those are data elements. We have the merchandise total. We have the sales tax, and sales tax is of course dependent upon the state that the customer is from. We have the shipping and insurance, the charge down here, and we have additional costs if we want our shipping to be upgraded. And then we, of course, have the total amount, okay? And then further, we have this catalog table. And again, you can tell right here that this is going to be a table. And a couple other things to notice, don't get quantity on hand mixed up with how many, which will be quantity, and also price. Notice where the price is coming from. It's coming from your catalog, your catalog. Okay, so first thing is our first assignment is to identify all the data elements. Okay, we look at the diagrams, we look at the data entry forms and reports, and we interview users of the current system because there might be things that we miss. And so this is our first attempt at collecting those data elements. We have customer name, customer address, customer phone number, order date. You can put stuff that you're going to anticipate that you need, okay? Catalog number, how many, catalog description, catalog price, total price, merchandise, total price, method of payment, credit card number, signature. So of course, be some type of electronic signature. Sales tax, shipping insurance, UPS upgrade, total US funds, total order for shipping costs, and quantity on hand. So this is our first attempt of identifying all the data elements that we saw in our data flow diagram and our forms. So, but now we need to break this down into smaller components. And right away, there's a couple things that we could break down as smaller components. The customer name, we should probably have the customer first name and last name. You never know with what we might want to do with these. Customer address, of course, can be broken up into all these components. Notice how I added a second address line. Just through experience, I know that a lot of times there is a second address line. Okay. Then now we identify our tables and assign the columns by organizing fields into the proper table. Okay. So again, a table can be set up for each entity and each data store. Okay. And we don't want to duplicate items. And so right away, we're going to try to figure out where to put these. And right away, I've identified 3 different tables based off of our data flow diagram. Okay. Catalog number. And again, we will never use a pound sign in SQL. So we just put catalog NO. How many, and this is appropriately called quantity ordered. Now, understand, I may change the names even further as we move along. Price, and we know that this price comes with the catalog table. Total price, it's a calculated field. This is going to be important as we go on also. Merchandise total price, method of payment, credit card number, signature, however we're going to do that. We need a place for that. Sales tax, and we know that'll come from the states table. Shipping, we know that'll come from the shipping table. Again, we're identifying two more tables right here. Shipping upgrade costs, we'll somehow do that. Total US funds, total order for shipping costs. So these are calculated fields also. Customer first name, customer last name, address line 1, address line 2, city, state, zip. Doesn't mean that this will be the only things in your customers table, because you probably will have other things as you move along, but it's a very good start according to what information we currently have. Okay. And then finally, the catalog table is pretty much given to us, and catalog number, catalog description, price, quantity on hand, and we come up with appropriate name for this. Notice how I put catalog in front of description and price. We might change as we move along because we know it's a catalog description, so we might just call this description as we move on. So each table must have a primary key to uniquely identify the record with the table. Notice a customer ID field was added to the customer table that will represent a unique number for each customer. Now, you could have a component primary key. We tend to stay away from that right now. Sometimes a component primary key, which is unique to the orders table or the customers table, we want to move away from that because it's hard to maintain. So in the orders case and the customer's case, we're going to add our own key. Okay. And the orders is going to have 2 foreign keys to the customer's table and to the catalogs table. Okay. But you see how we've added the keys to these tables that we've identified. Doesn't mean we're done with our tables yet, but at least we're getting closer. Okay. Now is the hard part. And this is where we normalize the data. Now, normalization does become second nature to a database architect developer. Okay. what you will find at this step is that some of the tables are already normalized, but some tables won't be. This step will help you determine whether, it'll just help you develop a better relational database. So the first normal form is a column must not contain repeating values. And, for example, if we had work, woke, topper, and crispy can in the same column, that would be repeating values. But also notice doing something like this is not necessarily good, because what if an order has orders 3 things from the catalog? Well, all of a sudden you have a big problem. So the best way to do this is to vertically stretch your table. We do that by putting each order on its own row, in its own row. And so that's taking it to the first normal form, okay? Now, we know some obvious problems here. We see some repeating values here. But the first thing is we want to get into the first normal form, and the first normal form is to get rid of situations like this. Okay? So let's move on. Now, the second normal form means that every non-key column must be dependent upon the entire primary key. Okay? So that second normal form, again, everything has to be in the first normal form before we can do that. Every non-key column must be dependent upon a primary key column, and the single column primary key many times is added to make it a unique primary key. Okay, and we certainly are going to do that. But we do have to understand something called functional dependency. One of the things we're going to be removing as we go into the second and third normal form is functional dependency. What is that? That is when changing a non-key column might cause another non-key column to change. So, for example, in this case, if we change catalog number, we would also have to change catalog description. That's a no-no. And so what does that happen? Well, we need a table for catalog, and we already have that table, of course. And so we do something. We will actually take the catalog description out, and we will keep it in its own table. Now, another thing is as we move on, we need to, sometimes we have situations where we have repeating values because there's a parent-child relationship. So when we take an order, we really need 2 tables. And the reason is that the order by itself has certain information that's persistent throughout the whole order. For example, the customer and order date are persistent for everything that you're going to order on that order. But some things are unique, such as the item that you're going to order. That's where you develop a 4th table that's directly related to the orders, and you call it order details table. Okay, and really it's a parent-child, and you can see how that works. Each order detail ID is unique, but the order ID is not necessarily unique. As you can see that it's repeating. So we don't have to repeat the order date for all of these. We don't have to repeat the customer ID for all these. That belongs in the order table. So this is, again, where we would add a 4th table to our database. Okay. Now, the third normal form is similar to the second normal form. Every non-key column must depend only on the entire primary key. In other words, watch for non-key field that is functionally dependent on another non-key field. So be in third normal form, again, we have to be in the second normal form. Every non-key field must be dependent only on the primary key column. And of course, which means it has no transitive functional dependencies upon non-key columns. Okay. So again, as we move there, we may have to add another table, and we're going to see that as we move along. Okay, so for example, the orders detail table, we go from this to this. Okay, and again, the catalog number is not dependent upon, when you change the catalog number, you shouldn't have to change the catalog description in the orders. So this is how we do that. And again, we knew we were going to have a catalog table, but we only need the catalog number, which is a foreign key to the catalog table here. And description will be handled by the catalog table. And there's one other thing that we're going to do, and I'm going to show you that we have to get rid of calculated fields. Okay, and calculated fields are dependent upon other values that are non-key fields. Okay, for example, the total price is dependent upon the price times how many or quantity ordered. So again, we don't want that dependency there. So we would actually remove any calculated fields from our database, knowing that we could calculate that in any report or any query. Okay, so what do we end up with? So finally, we would create the database and the tables that would be part of this new database structure. And here's what it would look like. Customers, of course, your primary ID is something that we've added. Customer ID, and pretty similar. But notice here, we're not going to just put state in. We're going to put the state abbreviation. We're going to make it a foreign key to another table. And that table is down here. Okay. So we call it state abbreviation, state name, state text. Okay. Catalog table. No surprises here. Notice though how we did put in catalog price. Even though we didn't put catalog in front of description, we did for price because we know that we're going to be using price for different things. So we don't want to get too confused. So you have to make a judgment call here, whether or not you want to include catalog price or whether or not you want to include catalog and catalog description. Again, it's because it's identified by this table name, you're fine either way. Okay. Orders. Well, we see what we're doing here. Order date, something that we just anticipate needing. Payment method. Again, it could be it's some type of flag. It might be 1, 2, 3, or 4. Credit card number. We don't go with VAR card. We go with card because we know it's always going to be 16 characters. Signature. However we deal with that, and it's up to the program to know how they're going to deal with this. So you just have to provide a placeholder for it. Sales tax, again, this is going to be derived from the states table, and that will be done programmatically within the computer programming. Shipping, we actually added another table for shipping. Okay. And shipping upgrade costs. You can do this one either way. You might be a true or false, whether you want to upgrade or not, and handle this programmatically, or you can carry some amount that you get from some other table. Up to you. And then, of course, we have to create our order details table, and like this one has two foreign key places that's related to other tables. So is this one related to, of course, to its parent and to catalog number. Quantity, again, we did have quantity ordered, but pretty much I figured to cut it down in price. Now, here's the thing with price is that programmatically you're going to have to figure out how to use this, okay? But the reason I left price here and here is because you're going to probably default the price to here, but this price on future orders could change, and you don't want to be dependent upon that. So, so you got to carry price, in my opinion. And states table, and you got state name. Sales tax is very important. You could have other rules, whether they charge sales tax, or whether they, for online orders, they charge sales tax. And then we added a new table, shipping, and we made this, we made our own primary key, shipping ID, description, and then the lower limit and upper price limit that will tell you what shipping costs you have, and then of course the associated costs. So you would do this all programmatically, and this is how you would do this program, this database. So I wanted to quickly show you how to do it. I wanted to talk about it. I want you to have this available for your project, so you know some of the train of thought that I go through as I do this. And then in chapters 11 and 12, we're actually going to develop our database and our tables, and we're going to relate them, and we're going to figure out how to do that. But I needed a little bit of time to be able to show you how to do this. So that's why I'm providing this video. So with that said, well, of course, if there's any questions, you can let me know, but just wanted to provide this for you so you know how to design a database. So see you in class. Talk to you later.